Hello everyone, myself Kunal Bhargav. In this video, we will solve the set B of second internal test paper of analysis and design of algorithm. So in this set B, we have 20 fill in the blanks and some uh, match the columns that we will find the answers of that fill ups and match the columns. So first of all, we will see the fill in the blanks. So first, dash is the process of finding the solution to a problem step by step. So the answer is iteration. Iteration is the process of finding a solution to a problem step by step. Now second, the time complexity of an algorithm is denoted by dash. So the answer is big O notation. The time complexity of an algorithm is denoted by big O notation. Now next, third, dash is an example of a dynamic programming problem. So answer is LCS, longest common subsequence. Longest common subsequence is an example of a dynamic programming problem. Now next question, fourth. In the dash approach, a problem is divided into a smaller subproblems and solved recursively. So the answer is divide and conquer. In the divide and conquer approach, a problem is divided into a smaller subproblems and solved recursively. Now next question, fifth. The dash algorithm finds the shortest path between two nodes in a graph. That the answer is Dijkstra algorithm. The Dijkstra algorithm finds the shortest path between two nodes in a graph. Now next question. The dash algorithm is used to traverse a graph in a depth first manner. The answer is depth first search. The depth first search algorithm is used to traverse a graph in a depth first manner. Now next question 7. The dash algorithm is used to traverse a graph in a breadth first manner. So answer is breadth first search. The breadth first search algorithm is used to traverse a graph in a breadth first manner. Now eighth question. The time complexity of binary search is, so the answer is 0 in bracket log n. The time complexity of merge sort, the time complexity of binary search is 0 log n. Now next, the time complexity of merge sort is dash. The time complexity of merge sort is 0 in bracket n log n. Now next 10th question. The time complexity of quickshot is, the answer is 0 in bracket n log n. So the answer, so it will be the time complexity of quickshot is 0 in bracket n log n. Now next question 11th. In the dash algorithm, the input sequence is divided into two parts and the search is continued in the part where the key may be found. So the answer will be binary search. In the binary search algorithm, the input sequence is divided into two parts and the search is continued in the part where the key may be found. Now next, this is a type of algorithm that always selects the best possible choice at each step. So answer is greedy algorithm. Greedy algorithm is a type of algorithm that always selects the best possible choice at each step. Now next, dash is a coding technique used to compress data without losing any information. So answer is Huffman coding. Huffman coding is a coding technique used to compress data without losing any information. Now next, 14th. This is an algorithm that finds the minimum weight spanning tree of a graph. So answer is minimum spanning tree. Minimum spanning tree is an algorithm that finds the minimum weight spanning tree of a graph. Now next, the time complexity of the algorithm of the Huffman's coding algorithm is, so the answer is 0 in bracket n log n. The time complexity of the Huffman's coding algorithm is 0 in bracket m log n. Now 16. The time complexity of the minimum spanning tree algorithm is, so answer is 0 in bracket m log n. The time complexity of the minimum spanning tree algorithm is 0 m log n. Now 17th. The time complexity of the longest common subsequence problem is, so answer is 0 in bracket m into n. Now next, the time complexity of the matrix chain multiplication problem is, so answer is 0 n to the power n. Now next question, the notation used to describe the upper bound on the running time of an algorithm is, so the answer is big O notation. The notation now next the notation is used to describe the lower bound on the running time of an algorithm is. So answer is omega notation. Now we will see the match the columns. Here we will see the match the column now first. First is binary search. Binary search we will match to the divide and conquer algorithm because this is an divide and conquer algorithm. An example of divide and conquer algorithm. Now next, depth first search. It is an example of graph algorithm. Now next, third breadth first search. This is also a graph algorithm. Now fourth merge sort. This is an example of divide and conquer algorithm. So we will match to the divide and conquer algorithm. Now next, quick short. Fifth, quick short. Quick short is an also a example of divide and conquer algorithm. So we will match to the divide and conquer algorithm. Now sixth, Huffman's coding. Huffman's coding is an example of greedy algorithm. So we will match to the greedy algorithm, and it is also a comparison technique. So we will find here two match for Huffman's coding, that is greedy algorithm and comparison techniques. Now seventh, minimum spanning tree. A minimum spanning tree is an example of a greedy algorithm. So we will match to the greedy algorithm. Now next, 8th, upper bound on running time. So this is the time complexity. So we will match to the time complexity. Longest common subsequence. This is an example of dynamic programming problem. So we will match to the dynamic programming problem. Now big O notation. Big O notation. This is an algorithmic notation. So we will match to the algorithmic notation. So thank you.